So we're going to take a look at this problem here. Simone wants 6 of her friends to share 84 photos equally. How many photos will each friend get? Let's think about this. What division and multiplication equations can model this situation? 84 photos divided by 6 friends. Or we could think of it as 6 friends times how many photos each will give us 84, or even how many photos times 6 friends will give us 84. So we're trying to find out how many objects in each group, since there are 6 groups. We can solve this problem using a variety of different models. We could create an array, an area model, or even use the distributive property to represent this problem. Let's start with the array. If we think about 84 divided by 6, we know we need to make 6 rows. We're just not sure about how many would be in each row. Well, let's think about it. 6 times 5. What if I start with 5? If I put 5 dots in each row and I fill that in, I know that 6 times 5 is 30. Well, I'm trying to get closer to 84, and 30 is not very close to 84. So what if I tried 10? What if I put 10 in each row? 6 times 10 would give us 60. That's a lot closer to 84. How close, though? So in my brain, I'm thinking 84 minus 60 that I already have. Well, I can subtract that in my head without even regrouping. 84 minus 60 is 24. So I need 24 more dots to finish this array. 6 times what is 24? Well, that's a basic fact. 6 times 4 is 24. So let me add 4 dots to each row and see how many I have. If I fill that in, 6 times 4, that new section, is 24. So I have 2 parts I did. I did 6 times 10 is 60, and I did 6 times 4 is 24. If I add those two together, I know that I have 84 dots total. Well, so what's the answer to my problem then? What is the answer to 84 divided by 6? Well, I had 2 parts. I had a 10 and a 4. If I add them together, I know that I have 14. 10 plus 4 is 14. So the answer to my division sentence is 84 divided by 16 is 14, or 6 times 14 is 84. So we have our array, and we've actually turned it into an area model here. If I take out my dots, I know that length times width, 6 times 10, would give me 60. And I know that length times width of the second rectangle, 6 times 4, is 24. So if I think of that as 2 parts of one larger rectangle, I know that 60 plus 24 is 84. So that's an area model. Length times width of the first rectangle, 6 times 10. Length times width of the second rectangle, 6 times 4, and then I add them together, I get 84. Well, what about the distributive property? Let's think about that total of 84 here. 6 times 10 is one of my problems. I have 6 times 10. But I added to that 6 times 4. Well, think about the area model. 6 is over here by that smaller rectangle. 6 times 4, that's my second part. So I'm adding 6 times 10 to 6 times 4. Well, when I look closely at that, I have 2 6s. I have a 6 in each multiplication part of that problem. If I pull that 6 out, I have 10 plus 4 left. So 6 times 10 plus 4, or in other words, 6 times 14, is another way of solving this problem. And if we look at the top, we know that 6 times 4 is already 84. If that's the case, 6 times 10 plus 6 times 4 is 84. And 6 times 10 plus 4 is 84. And we also know that 6 times 14 is 84. So we've solved this problem using 3 different representations. We used an area model, we used an array, and we used the distributive property.